Hey Jeff, about how much longer do you think we can take targets in this area?
About 2.5 hours,
Oh, okay.
a little less than that. Say 2.25.
Cool. Thank you.
540 is our limit.
Are there any I should prioritize then, Stefan, do you think? Or
It's more like I think we might need more targets.
okay. Oh, sorry, yeah, because it's 200. I was thinking three or 400. Yeah, yeah.
Yeah, no, most of these are short. These are pretty bright targets for the rest of them. Okay, yeah, I had a few new targets just in case.
I'll be back in a few.
Okay. Yeah, it looks like we'll be able to hit M31 until about 4:45, 4:30-ish, and then probably do standards, and then we have like a couple transients after that. Especially for the brighter targets, we can usually get to like 1.4, 1.5 air mass. Oh yeah, I guess we should introduce ourselves. So for the Salvation team, my name is Stefan Kimura. I graduated from Willamette University with a degree in physics in 2018, and I've been um, working with the Salvation group now for about 3 years. I'm based in Kona, Hawaii, so I'm doing all of this remotely on my laptop. I am usually the one in the Salvation team who kind of gets the logistics of the observing night together. We find all the I do most of the target finding, and then um, scheduling when we do observe each target. And then usually I'm the one giving the commands to the telescope operator who is in the 121 ROR, this room over there. But Richard Smith here, who just joined the team a couple months ago, has been running the telescope these last few months. I don't know if Richard is here, if he wants to introduce himself.
Yeah, when Zoom starts to behave again. Yeah, hi, I'm Richard. Yeah, as Stefan was just saying, I've sort of joined the Salvation team. I think it was about a month and just over about a month and a half ago, I think it was. Yeah, I'm also based in Hawaii, but the other side of the big island in Hilo. So again, doing this all virtually. I'm originally from Northwest England, did my PhD at Queen's Belfast. And this taking spectroscopic data, as we're doing here, is pretty new to me. I've done taken photometry before, but not spectroscopy. So I'm still in training, basically. Yeah, I'm not sure. I can't see on the camera now. Oh, I know I don't think they're back yet, but yeah, if there's any questions, as Stefan was saying. Oh, there you go. What does salvation stand for, Stefan? I can never remember.
No, yeah, sorry, I didn't want to interrupt you, but yeah, so salvation stands for spectroscopic analysis of luminous variables and transients in our neighbor. And our neighbor in this case is M31, or the Andromeda galaxy, which is a galaxy just like our own Milky Way, about 2.5 million light years away. So it gives us a really good opportunity to study a very similar galaxy, since we can't really look at our own galaxy too easily. We're taking spectra, which is what you see in that little pink box over there. It helps, we break down the light from stars, and it helps us kind of determine what's going on over there. I have a hard time explaining exactly spectroscopy, but there are other members of our team who are much better at explaining, but they're not here tonight. Right now, it is just me and Richard. There are, I believe, 8 of us on the Salvation team. It's led kind of by Dr. Raja and Dr. Monica Sarasa, who works at NOIRLab. We also have Rafael Nunez, who is a graduate student at San Francisco State University, and he also just graduated from UC Santa Cruz. He's the one who's kind of the variable star and spectroscopy expert here, and he's the one who he's been kind of picking the targets and doing a lot of the analysis on the variable stars. He's been the one who's been classifying them, and I think he has a paper that's coming out shortly. He also recruited Joe Bonin, who's another graduate student at San Francisco State University, and he's been working with Raphael and Monica on a sort of machine learning project where we we can take different spectra of stars and sort of classify them. But there's so many variables within these stars that it takes a lot of machine learning, We also have, there's also Kevin McKinnon, who's a PhD student at UC Santa Cruz. He's kind of like one of those guys who he's not around too much, unfortunately, anymore, but he's someone we can ask for advice. He's done a lot of observing, especially a lot of spectroscopy, and he's really helpful with the data analysis as well. Stephanie Figueroa, she just graduated from UC Santa Cruz, and she's out in the real world now. She's no longer working with us, but she was the one who was taking a lot of the data and reducing it so we can use the data, and we take the spectra and reduce it. And then we also have Manan, who is a recently graduated high school student in India, and he's been kind of learning to take over for Stephanie. So he's been learning the basics of spectra reduction using Python. And I think that is everybody. Jeff, if you want, I don't know if Jeff is there, if you want to introduce yourself real quick too.
Oh, sure. My name is Jeff, of course, and I'm the telescope technician. My primary job during when I'm on day shifts is repair and maintenance, setting up the instruments, making sure the right gratings and dichroics are in for the observers for their evening run. When I'm on night shift, it's operations, point the telescope in the right direction, track a star so the observers can gather their science. And my primary responsibility is to make sure that the telescope is safe from any kind of adverse weather events. And that's it in a nutshell.
Cool, thank you.
Yeah, I think I'll just give a brief commentary on what we're doing now, basically. Yeah, so we're currently taking exposures. So that's why I'm flipping between these two panels, just checking these two exposures are still being taken. Okay, there's no issues. I think it's safe to say because we're in the early hours, is in the lower energy part of the night. But we've all got different jobs to do. It's all, as Jeff was saying, it's keeping the telescope safe and making sure it's operational, etc. And checking the instrumentation on this side and the exposures. So a lot of observing is sitting and checking your data, checking the conditions, etc. And as you might have seen just briefly before, Stefan updating the target list, which is what we've got here. So look, not only checking what's going on with the data, instrument, and telescope, but thinking ahead. We've only got a few more hours left. Do we need to prioritize targets, add more, etc., depending on where they are in the sky. So just a brief overview of what's currently going on.
Yeah, and then the M31 targets that we've picked there, those M31 variables, Raphael and Monica at the beginning of our project in 2019, I believe, they chose a bunch of stars within M31, the Andromeda galaxy, whose light curves or whose brightness kind of varies a lot in time. So, if, Richard, if you want to click one of those, you can kind of show how the light curve. So you can see how much it varies. But if you take a look at these graphs here, plots brightness on the y-axis or magnitude, and time on the x-axis. So you can see it's got a little bit of variation over time. So we want to see what this star is doing by taking spectra of it at different points in time, and we want to see how it changes. And that might tell us a little bit about what's going on in there. I think we've been taking, spectra of a number of these stars for about 4 or 5 years. I think this is the fifth year we've been taking them. So some of these stars we've taken maybe a dozen or 2 dozen exposures now. We've seen that they do kind of evolve a lot over time. That might actually, why don't we wait until we change targets in a little bit, and then you can kind of just see the process of how the telescope operator picks up a target within a field. Typically, the field is, or when we're looking at stars, the field is not crowded enough that it's too hard for us to pick up a specific star, but sometimes in really crowded fields, it's hard to take observations of spectra of these stars. But in about, I believe, 3 minutes, we're changing targets. Yeah, so in that purple window on the right side of this, on the top right corner of the screen, you can see that there's a star in that box over there, that green box, and that's basically a guider star. Our telescope kind of tracks it or hones in on that star and uses that star to track all the other targets. So that helps us make sure that we're staying on our target and not any other stars within the field.
Okay, just waiting for the red CCD.
was thinking we probably skip that really long exposure because I don't. Actually, oh, we have plenty of time.
Yeah, I was just thinking because
Yeah,
obviously
just
longer
go for it.
exposure means it'll be
Yeah.
fainter. So if it's
Yeah, I thought
oh yeah,
for some
I
reason I
can
thought
skip to
M30.
the
I thought M34 was lower in the sky. Is actually.
I can skip to the
Yeah, it
green
might
stuff.
actually. Yeah, it's getting kind of low. Yeah, let's do some of the brighter targets.
Yeah,
Yeah,
yeah.
sorry.
Um,
It is 1 p.m. or 1 a.m. here, but it is not 1 a.m. there.
Go the wrong way in the list. That's the one. Okay, sending to Poco.
The PA when you have it.
So if you look in that window in the top right corner, you can see the telescope actually moving to our next target right there. Those streaks are the actual stars, but they're streaks because the telescope is actually moving right now.
And the PA is 77.
Okay. Okay, I'm guiding. You can begin.
Great, thank you. I think we're here for about 10 minutes or so.
Yeah, the nice thing about later nights is we get shorter exposures usually, so we have to stay a little more awake. Can't fall asleep.
Yeah, and just to briefly explain what I'm doing here as well. So we've got the target list here that Stefan's been populating throughout the night as well. And then we've got the observing log. So for each night, we just record what data has been taken and the number, the sort of generic number that the observation has, so that when it comes to processing the data, we know which file is which object and etc. So as soon as we start exposing, we add the object, exposure time, and number of exposures. So then it's recorded, and then obviously if there's anything goes wrong, if something's miscalculated, or we suddenly have to stop the observation, we can add it in as notes here. So again, so in 6 months' time or a year's time, for example, you can come back to this and know exactly what happened to the data.
Yeah, sometimes we have more exciting targets, but tonight we're mostly just looking at M31, variables within M31, which is actually the main focus of this project. Last month when we were able to get on Sky, we were observing for one of Dr. Raja's colleagues, Professor X, and we were looking at fast radio bursts, which is something that I've been pretty interested in for a while, which was kind of cool to learn about. And we were able to take spectra for them and help some of Dr. Raja's colleagues. I think they're in the process of also getting a paper out for that. But also, since M31 is basically directly overhead, we are able to observe it pretty much all night. I think we only had one transient before. Yeah, we were able to get on M31 pretty much less than half an hour after sundown, which is really nice. And it'll be up pretty much the entire night. So we can get a lot of targets, especially which is nice, especially because last month, our second observing night of the month, we weren't able to get on Sky at all. It was quite humid and we were never able to open up, which was quite unfortunate. I think Richard last month he got the full experience. So we had a very smooth night. I think that was the first night he had was probably the smoothest night I've ever had on the telescope. And the second night we didn't get on Sky at all. So he got the full experience in one weekend. Yeah, if you guys have any other questions, please feel free to ask or ask in the chat. I think at this point, Richard, Jeff, and I don't have too much to say. I think we're just trying to survive. So please, if you have any questions, let us know.
Okay, just waiting for the red exposure now. Okay, sending next target to Proco.
Got it.
And oh yeah, I've done it right there. PA is 75.
Okay. Yeah, I'm guiding. You can begin.
Great, thank you. And again, another 10 minutes-ish here. Has moved over, yeah. Yeah, just to sort of build a bit on what Stefan's message as well about really interesting targets that pop up. I don't know if I'm not sure if it is the same system. I can't remember the name for it, but with a number of telescopes around the world, they're able to get almost real-time alerts to them. So, for example, if something of particular interest suddenly happens, like for example, at a gamma ray burst, for example, and the alert goes out to the certain set of telescopes saying, "Stop everything. We need you to look at this if you can." So there's that sort of system as well, where if something completely unexpected or very interesting pops up, and data is needed straight away. For example, it might very quickly brighten and then become faint again. There are a number of telescopes around the world set up to do that. I've previously been to the Isaac Newton telescope on La Palma. This wasn't doing spectroscopic observations. This is my first time really doing spectra, but they were set up to receive some alerts, and it was quite interesting actually. They had a sort of regular operations manual for your observations, and then another manual which was, if you get an alert, follow these instructions. So yeah, there's multiple different systems for sort of immediate observations, and then through, for example, the Antares system, where it's an interesting target, anybody can have a look.
Yeah, and I believe the entire system uses the Zwicky Transient Facility, and that uses the Palomar Observatory in San Diego. So
right.
very nearby. Yeah. It's kind of nice. Therefore, we know that pretty much anything they can see, we can see for the most part.
Yeah.
And then one of the leaders of our group, Monica, she has her own filters, which help us kind of pick out the more specific to our project, those transients. So those go through her computer, and then we can see them. It comes through Slack, actually. And then from there, we can pick our targets. Because if not, I mean, Antares has probably tens of thousands, if not hundreds of thousands of alerts that come through every day. So we have to filter out the ones that are interesting to us.
Yeah, I'll just talk through this very briefly. Yeah, so this is just to have a look, double check the weather report, basic current weather. So these are all the humidity, wind speed, etc. values. on Mount Hamilton, where the telescope is based. And on the left here, you've got the I think this is the all-sky camera. So showing a very nice image of what you can see if you're up on the mountain, more or less, anyway. Yeah, and every observatory will have systems like this where it can measure the humidity, etc. As Jeff was saying, because the priority as well is keeping the telescope and the mirror itself safe. Yeah, so being ready to close up if the weather deteriorates.
Yeah, like I was saying last month in September, we were unable to pretty much open up at all the second night. Humidity stayed too high. It looked like we were pretty much stuck in a cloud the whole night. We were just hanging out, hoping for the best, but it didn't happen. So unfortunately, Jeff will have to be the bearer of bad news if weather takes a turn for the worst. But so far, we're so good tonight.
I think the next target isn't in the system, possibly.
Which one is it?
ZTF 20AAN.
That one might have a different name in it too. Let me pull that up for you.
I can jump to the next one and come back to that one.
Okay, yeah, cool.
Yeah.
Yeah, you can try that too.
Okay, ABH.
Q, yeah, I see it. It's that third one with the that's doubled up.
This. There, yeah.
That one, yeah, right there.
Thank you. Okay, sending to POCO.
Yeah, unfortunately, because we get our targets from Antares, sometimes these stars are a little too close, so they end up overlapping, and sometimes they end up getting two different names, which can be really confusing. So you see, if you see in that list over there, there's I think there's a total of 6 or 7 stars which have two names. So you have to be real careful when we're doing those observations.
Yeah, the PA is 72.
Yep.
Just double check. So it's this one, yeah, 200. Yeah, I was getting rid of the second designation in case the / in the object name causes any issues with the file itself, loading it in or saving it, for example.
Cam guiding, you can begin.
Great, thank you. And 10 minutes here.
Yeah, at this point, we're taking real short exposures because these targets are a lot brighter. Earlier in the night, we were taking targets, I believe that were about 18 to 19 megs. So we were on those targets for about 45 to 50 minutes, or exposures of 15 minutes, and we'll take 3 of them. But typically for these brighter targets, we take exposures of um, 200 to 400 seconds, and we'll take it 3 times. And we try to take multiple exposures because if you look, especially if Richard can pull onto the red side, especially if you look at the red side spectra, you can see there's a bunch of these little squiggly things that look like worms, but those are cosmic rays, which kind of mess up our data. But if we take multiple spectra, we can use our data reduction, and we can remove them, but remove the cosmic rays. But that's why we take multiple, so we can reduce them. And if you look, I don't know if you can really tell, but the red side gets a lot more cosmic rays than the blue. It's always something worth pointing out.
Oh yeah, you can say yeah, barely.
Yeah,
Barely
that's why
any
when we take,
visuals on this one, yeah.
that's why when we're doing the calibrations, you notice that the red sides are, those exposures are a lot shorter. I think they're a lot more, I guess, sensitive.
Yeah, and I do like looking at the sky cams. It's not sort of not quite professional astronomy, but I do enjoy looking at them.
I'm going to step away for a couple minutes. I'll be right back.
Yeah, no worries. Yeah, and again, if anybody has any questions at all, there's no silly questions, especially not at 1:30 in the morning here or 4:30 where the telescope is. Yeah, do feel free to ask.
A transient is basically an object or something in the sky that we see that comes and goes. So it's usually something that changes in brightness. So in most cases, it's something like a supernova, something that explodes. So the telescope is basically taking pictures of the same part of the sky constantly, and then it'll compare images. And if it sees a change in in the image between one point in time and another, that's when we get an alert that something has changed and something has shown up in that point on space. So then we'll look at it and we usually see something like a supernova, or we call a CV or cataclysmic variable, which are the main types of transients that we see here. But basically, transient means something that comes and goes, something in the sky that we see and disappears.
Yeah, I don't think solar system objects, so asteroids and things, are classed as transients. That's where my expertise is originally. I think they'd be moving objects rather than transients.
Yeah, I mean, although that's something we actually have to filter out of our alerts. We often see a ton of those SSOs or solar system objects. They show up as these little moving rocks. Yeah, actually, do you want to pull up one of the Antares links, maybe of the transients towards the bottom?
Yeah.
Yeah, you can show, go down to the thumbnails, the three thumbnails.
Yeah.
Yeah, so if you look, the thumbnail on the far left, or not the far left, the one on the left right over there is our historical image. So that is the image Antares has of that part of the sky and what it usually looks like. And then the image in the middle is the current image. So you can see that it's a little brighter in the middle. And then the image on the right side is the image in the middle minus the image on the left. So it shows the difference in the two images. So you can see that little white spot showed up between the normal image and the current image. So that we see some sort of transient event right there. So we took that and we believe it to be a unidentified, or I mean unclassified supernova. So we'll be taking spectra to classify that and then hopefully send it to the ATEL group. Yeah, for a while there was something wrong with the Antares filter that Monica had, and we were getting a whole ton of these solar system objects.
Okay, just waiting for the red exposure again. Okay, sending to Poco.
And PA?
The PA is 72.
Yeah, I'm guiding. You can begin.
Okay, thank you. Yeah, again, 10 minutes. Yeah, just to reiterate again, thank you everybody for joining us. It's been really it's been really enjoyable showing how things are done, and yeah,
Let's
it's been really
thank Richard
interesting and
because
good
we
questions.
kind of just threw him into the fire. I don't think we even told him that this was happening when we first started doing this. He's just been great on going along with all of this and helping out and explaining what he's been doing. So yes, thank you, Richard. I realized I don't think Monica ever really told you this was happening.
No, I don't think so. No, it's been good fun. Really enjoyed it. Yeah. So, recording.